My name is Randy Brandberg. I'm the Business Development Executive for Raytheon Sea Power, just up the road in Portsmouth. It's certainly an honor to be here in really the closing session for the day. And we're going to end up on some topics around innovation from undersea technology. And we have a couple great panelists. And I'm just going to read a very brief part of their bio, invite them up. We'll get through both their presentations, a few questions at the end. And then I know happy hour is right behind us. So it's always dangerous to be either right after lunch or right before the booze. It's always a bad place to be. Hey, so first, Dr. Mark Abbott, who's President Director for Woods Hole Oceanographic Institute. Dr. Mark Abbott is the 10th Director and President of the Woods Hole Oceanographic Institute. Dr. Abbott previously served as Dean of the College of Earth, Ocean, and Atmospheric Sciences at Oregon State University. He joined as an associate professor back in 1988, following 6 years as a member of the technical staff at the Jet Propulsion Laboratory. His research focuses on the interaction of biological and physical processes in the upper ocean and relies on both remote sensing and field observations. Dr. Abbott has also advised the Office of Naval Research and the National Science Foundation on issues regarding advanced computer technology and oceanography. In 2011, Dr. Abbott was the recipient of the Jim Gray eScience Award presented by Microsoft Research to a nationally recognized researcher who has made outstanding contributions to data-intensive computing. Those of you who know anything about Woods Hole knows the gem and jewel that they are to the research in oceanography, automated systems. Those of you who were here last year got to hear Dr. Jim Bellingham talk a little bit about the great work they do, but Mark's got a terrific team, so please welcome Mark up here to join us at the table. Next, we're going to have Ronald Vien, Technical Director of the Naval Undersea Warfare Center, Division Newport. Ron Vien serves as the Tech Director of the Naval Undersea Warfare Center, Division Newport. In his role, he is responsible for providing research, development, tests, and evaluation, engineering, analysis, and assessment, as well as fleet support capabilities for submarines, autonomous underwater systems, and offensive and defensive undersea weapon systems. He stewards existing and emerging technologies to advance the state-of-the-art in undersea warfare. Mr. Vien concurrently serves as the Director, Undersea Warfare Systems Engineering, where he's responsible for oversight of 12 warrant holders to ensure that the Navy maintains its position as the foremost technical authority over a broad portfolio of undersea warfare systems. Again, what NUWC means to this entire region is, I just can't overstate it. So, great group. We're honored to have you here. Ron Vien, please come join the table. And Dr. Abbott, I think you're first. Or is Ron Vien first?
We're going alphabetical.
All right, Dr. Abbott's first.
I'm used to it. And I'm used to always being in the front. You know, the kid always in the front row in the left corner. So this is going to be a quick jaunt. It's a little bit different. I always like giving a talk right between you and drinks. But I want to talk about innovation in kind of a little bit of a different way. Some of the messages you've heard today. But let's go to the next slide, which is really something I got from Danny Hillis. Danny's a member of the Defense Innovation Board. He invented the connection machine, which was part of Thinking Machines years ago, a real thinker. And this is kind of his timeline of innovation. And you heard a lot about from Admiral Johnson and others that really when you're an explorer, the world is wide open. You know, there are lots of opportunities, not very rigorous. And then we move to this transition into settlers and lastly, town planners, which are very rigorous, not much opportunity. And the challenge for us, even in the academic world, is that sometimes we are so used to being funded to do very rigorous things, the best possible science, that when we go into that sort of exploratory side, we bring that very rigorous sort of town planner mentality to the party. Let's go to the next slide. And this is something that Mark Andreessen wrote over a decade ago, which was, he said, software is eating the world. It's all becoming software driven. You may have seen a commentary in the Wall Street Journal last week where it was added that models are really the things that are eating the world, that companies are gathering data constantly, making their products better, they make better models, and then that feeds back into making better products. It's really a closed-loop data system, end-to-end, not just collect data, improve, and move on, but it really is that continuous improvement. And the writer mentioned a couple of things that we need to do, which is open up all of our data, think about the organizational structures that make this happen, and it brings together, which is something he didn't mention, all sorts of compliance and, for this community, security challenges when we start opening it up so we have this frictionless process. That's what's going on in the commercial sector. How do we think about it in our world? Go to the next slide. Let's talk about an example of a different one. And you've heard some people mentioning the auto industry, and if you read the newspaper, you know that really Ford and Audi and BMW are trying to understand how to work in the Silicon Valley world. Things are changing. There's a lot more computers on board your chips, coding, advanced manufacturing. You're starting to see different sorts of players come into the market, like NVIDIA, into the auto industry, new kinds of models and ways to do things. But let's look at the next slide. If you look, quote, under the hood of your car, this is what's there. It's the wiring harness. It's big, it's complicated, it's trying to support, if we go to the next slide, the next generation of activities. It's interesting to note, it's the third most expensive component. It's the third heaviest component of your car. There are only a few suppliers. It's very proprietary and it doesn't scale well. So when you look at a car today with all of the sensors and cameras and everything in there, it has to fit within that wiring harness. Go to the next slide, and this is a problem. The auto industry wants to move from mechanical devices to electronic-based control units, ECUs, basically move into the digital era, but fit within a network where there are 5 different networks with 5 different proprietary protocols. Go to the next slide. This is what they're trying, where they are. On the left-hand side, all of this heterogeneous, that wiring rat's nest, that third heaviest component of the car. And if you look at what Audi and others are doing, mainly in the European car companies, but the US are doing it as well, they're hardening Ethernet to support that infrastructure. They are moving into a PC Silicon Valley era where the network is very open and easy to plug in new sorts of capabilities. So we go to the next slide. This is what they're looking at. The next generation automobile is going to produce and consume 2 to 3 terabytes per day. It's talking to all of the sensors around there, other cars, the traffic light systems, construction sites, the whole bit. They've got to get to this idea that the car is just a data center, which is why Ford and the rest are scared, because they're worried that the Apples and the Googles are the ones that are going to own that data, and the data is really the crown jewel of the automotive industry, and they're worried we're just the ones who are going to provide the axles and the engines and not own the data. Go to the next slide. If you look inside an underwater vehicle, it kind of looks like that wiring harness right now. There's a control system for the navigation and a control system for the propulsion and a control system for the sensors. And trying to get them to talk is a hard problem, and sometimes the operator says, you know, this is $1 million vehicle. I don't want your software models that are being based on sensors to drive my vehicle and I lose it. So this is a real challenge. How do we as vehicle developers and designers begin to move into this sort of Ethernet data-driven world where there's much more open and stable architecture? Go to the next slide. The next part of that is every one of those components, that sensor, that propeller, whatever, is going to have a semiconductor in it. It could potentially have smarts in each component. So if you look on the left, this is what IBM is looking at. There's a microprocessor, there's memory, there's communication, there's power. It's on a board, which is a millimeter square, and IBM is looking at processes where they can stack those 64 high. So it becomes a system of boards. Think about the amount of processing and intelligence you can embed throughout that vehicle, linked together by an Ethernet network. Go to the next slide. Say, well, that was just automobiles and that's cool stuff. This is actually the Norwegian oil fields, the standard oil platform on the left. The little yellow one is an autonomous oil platform. So they are looking at basically bringing that same sort of networked autonomous systems out into the oil fields. Go to the next slide, where these devices are controlling up to 8 to 10 different oil wells, totally without people on board. Reduces costs. They're able now to pursue fields that are much more difficult to get oil from, but they're able to do it with an economic advantage. Go to the next slide, and this is the world I used to be in. The space industry is undergoing the same sorts of revolution. We heard about Elon Musk. One of the things Musk did was say, do I need radiation-hardened chips? That's the NASA way to do things. Turns out radiation-hardened chips tend to be 5 to 10 years out of date. He said, you know, I'll just use commercial off-the-shelf and I'll put in 10 of them. And that gets me my redundancy that I need. Now it also puts me on state-of-the-art chip technology. But you know, if you look at NASA, this is the Earth Observing System satellite, Terra, $1 billion, and 10 years later. If we go to the next slide, sometimes these big things end spectacularly. Go to the next slide. Sometimes not so spectacularly. This is a NOAA weather satellite where somebody forgot to tell the developers that they borrowed some bolts from the tilt table and literally tilted. And luckily, nobody was sitting at that desk that you could kind of pick out on the right-hand side there. But if you go to the next slide, this is now some former engineers from NASA at Planet Lab said, you know, we just can't spend our career on these 10 to 20-year missions. It's just too slow. We're not able to innovate fast. Planet Lab said, we're going to use that CubeSat technology. They are now up to roughly their 15th generation of land imager. They've been in business for about 5 years. And if you look at the next slide, this is not an artist's rendition. This is an actual photo from space station deploying these CubeSats. They've lost about 100 of them due to various failures. But they can tolerate failure. They approach risk in a very different way when things are networks of low cost but fairly capable components. Go to the next slide. This is where we're moving. And I know I get in trouble with the CNO because he talks about the OODA loop. But if you really think about networks of systems where you're gathering information from a whole variety of sources, and this is something Gilman-Louis talks about. It's really a sense, share, integrate, coordinate, and then act. It's coordinating a lot of different and disparate and sort of unexpected data sets from other sources and pulling those together to deliver a new kind of a service. Those networks are much less predictable than what we've had in the past. Go to the next slide. This now then plays into the kinds of decisions we need to make. Most of the decisions, there's a lot of uncertainty. They're really complex. It's not just a simple point solution and move on. We're trying to understand risk, and we're trying to model that risk and figure what are the actions we're going to take in that. And risk models, this is a little bit of sort of social theory here, are really a mix of realism, precision, and generality, and as every engineer knows, pick 2 out of 3. But you know, if you look at climate, there's a risk problem where you really don't need a very precise model, but you really want to be able to understand how do I adapt to climate change to manage that risk. Terrorism, another one where maybe you don't need a general solution to terrorism, but you want iterative risk. As the terrorists come up with different kinds of threats, you can respond to it. So these kind of networks, these sense, share, integrate, coordinate, act approaches really kind of play into the kind of observing and modeling systems that we're trying to put together. And so it's really interesting to start thinking about that, these risks and opportunities in network systems. Things appear that you didn't expect anywhere. It starts to look like what your kids or your friends do, which is network gaming. Network gaming is basically just some sort of augmented reality, simulation, and real-time analytics. It becomes an interesting metaphor for thinking about how we work with these complex networked systems. Go to the next slide. Ever been inside an Amazon fulfillment center? Doesn't look very organized. This is what Bezos does. He says every item that comes into the warehouse gets tagged and put on the nearest available shelf. So they know where it is, but it's not organized by, you know, here are all the paper towels, here are all the books, here's all the the toy cars or whatever. What he does is he's beginning to learn how products come in, when they get ordered, and he's using that data sensing and modeling and integrating based on looking at what times a year are people buying certain products. Do I need to move them to the warehouse here, et cetera, so that it looks like chaos, but it's very much a data-driven model that's out there. And so when people laughed when he said, I'm going to compete with UPS and FedEx because he doesn't have the physical infrastructure, he has the data and he has the models to provide that service faster than a UPS and FedEx that may not be quite so nimble and facile in understanding how products get ordered, delivered out to the customer. If you go to the next slide, DARPA, and some of you may have been at this meeting last December, their Ocean of Things. It's kind of the same model that they were trying to put together. Thousands of small, low-cost floats coupled with data analytics. Think about the security issues associated with that, but the notion was that by having the data and having smarter analytics, we would be ahead of our competition. Next slide. This is, I sometimes call this a vision or a hallucination. At Woods Hole, we have a dock, we've got to rebuild it, but maybe part of that dock is some sort of airborne deployment system for smart, low-cost sensors, deploy them in a grid out to a network of small satellites that we can begin to be much more responsive to what's going on in the ocean and learn in that way. Next slide. This is really what we want to do. We all want to make the ocean transparent. Our competitors talk about making the ocean transparent. The technologies that we're talking about today really weren't around when a lot of us were graduate students. And really a lot of our scientists and engineers out in academia, largely funded by a National Science Foundation or Office of Naval Research or NASA or NOAA, generally don't support this kind of free-range thinking, that explorer part of thinking, the left-hand part of that innovation curve. So you go out there in the labs and you find a lot of one-off systems, very long design cycles. None of those are moving as fast as what we're seeing out in the commercial sector. So one of the questions you might ask ourselves, what if the hardest problem, the most expensive thing in an ocean system was 10 times cheaper? What would we do there? Would we deploy more? Would we be able to tolerate more failure? How would we work? So if we look at the next slide, this is really one of the things that starts to get to be more of a cultural thing. It used to be to go and do ocean science was limited to those with big CapEx budgets. You know, if you wanted internet, you had to go to a government lab or a university. You don't do that anymore. You can do it at home, you can do it from your car. That high cost of entry really restricted the size of the universe of people who could play in that ocean sensing world. If these things become $100, who can play? And it's also not just a nice straight pipeline like McNamara's put together 50 years ago from 6.1 to 6.5. It's a much more of a network process where ideas get remixed. Capabilities that we didn't expect come from other sources. You can go and look at Uber's engineering pages, which are really quite interesting. Uber, Airbnb, and other companies that we think of as just sort of service providers are huge software developers, and they're driving the industry forward. If you look at Uber's visualization strategy, they draw upon Pinterest and LinkedIn. You go, wow. They're not drawing upon Microsoft or Oracle or anybody else. It's a very different world where there's a lot of this sort of remixing. Because we're talking networks, you've got to anticipate the unknown unknowns. Ideas and capabilities are going to come from a lot of places that we don't expect, because it's not just the big folks who have lots of capital. Anybody with a good idea can access data and develop something. Even semiconductors now, it used to be you had to have $1 billion to get a custom fab. Now at the last Semicon meeting last July, a husband and wife team in Medford, Oregon said, well, we can actually economically deliver 5 wafers to you. Custom silicon. That used to be just unheard of. So these are the things that have changed, and those partnerships are much more fluid between individuals and institutions, as well as being much faster. If we go to the next slide, don't forget the kind of workforce that we're dealing with, and we're seeing this in the universities as well. This came from IBM. It's interesting that the Gen Y folks there are very poorly represented in aerospace and defense. They really would rather, we saw an example of this, a tragic one a few weeks ago, people learn how to fly airplanes virtually or play war games and video games. They don't really want to come and work in a big industrial complex. Go to the next slide. Next slide. Again, it's not just the technology, it's the way people make money. This is the classic innovator's dilemma between the incumbent and the insurgent. Insurgents are willing to destroy the existing business. Incumbents want to just get ever larger margins. Insurgents tend to be faster, and they tend not to want to lock in. Are we moving into that world? You heard from Admiral Johnson this morning, making everything digital, not just making paperwork digital, but all of your data, everything digital is part of that transformation. Hennessy and Patterson, who won the Turing Award this year, talk about the next generation of chip manufacturing. And they say this is going to be something we see very rapid improvement. It's basically into customization at scale. The fact that for $10,000 you can get custom silicon is going to lead to a very fast cycle in semiconductor technology and performance. Go to the next slide. And in some sense, we're starting to think it's kind of back to the future. This is from a paper in Acoustics Today from a couple of years ago, looking at World War II and how we were organized as a nation. And there was Vannevar Bush, the endless frontier, up there on the left. And he had all of these labs underneath there. You noticed that he had industry, Westinghouse, companies that really aren't doing that much anymore, RCA, Woods Hole Oceanographics, University of California. So there was this recognition that there were the government labs, private sector, and academe working together at kind of the same level. Go to the next slide. Just want to talk a little, end up here with a little history. So that previous slide was from World War II. 10 years later, the CNO was really nervous. Because he was nervous because he was under the impression that the Soviets were going to build 100 nuclear subs a year, that they were very capable subs, and that he was not positioned right. He was positioned to protect surface convoys in the North Atlantic. And now the threat space was different. The technology was really different. So he went like all good CNOs do. You go to the National Academy of Sciences and say, I need some help. That spring, they proposed a study, funding from ONR and Woods Hole Oceanographic, no less. Go to the next slide. Created something called Project NUWC. Those of you who've been to Woods Hole know that there's NUWC Point, NUWC Lighthouse on Cape Cod. Invited 60 people, Navy officers, Navy labs, universities, private sector. They took a mansion, converted it into a top secret facility, and started in June. Of course, you put people on the Nautilus, which was the nuclear sub at the time. 3 months later, they delivered their final report and closed out. One volume is available, slightly redacted. One volume is still classified. What came out of that report were things like moving from the skipjack class of attack subs to the Thresher class, i.e. moving the sonar bulb forward. The whole design of the torpedoes that the Navy uses today came from that meeting. A chance encounter between the CNO and Edward Teller led to the Polaris missile and the undersea launched missile for the Navy. Completely created the nuclear triad and much of the technology that we've lived on for 50 years. If we go to the next slide, if you read through those bullets, you say, wow, this looks like what we're doing today. Faster designs, small specialized investments, ocean acoustics, bottom surveys, underwater communications. But it's interesting, the smaller one, which it says, we've got to think boldly, not for its own benefit, but provides a mean whereby evaluated new ideas and techniques can be translated into full-scale construction. I think I've heard that about 10 times today. So it's interesting that here we were in a really dangerous part of the time for this country, and we convened a small group, worked really hard together, and transformed the Navy's entire posture. Go to the next slide. So final thoughts. That's interesting, useful to remember, some good lessons to learn, but it's a different world again. The intelligence is everywhere, not just in the people, but in the devices themselves. Everything gets connected. You can't just say, well, I can pick the 10 big defense contractors and therefore I know all the sources. There are a lot of people out there. The barriers to entry are really low. There's a lot of remixing and innovation that happens at scale. That is, you can remix something and come up with a big new idea pretty fast. That leads to really unexpected capabilities. It means kind of rethinking that whole strategy that Admiral Johnson talked about today of thinking about the sort of development operations and then the R&D. The last part is how do we engage with that technology landscape when we don't know who's building those chips, who's embedded that software. Thinking about things like blockchain and other new kinds of technologies, we've got to think about how do we engage with the world and protect our assets and our nation. So I'll leave it with that. Thank you very much.
Thank you, Dr. Abbott. Great speech. Do the same. Yeah, I got it. You know, every day when I go to work, I walk in and there's a slide or a post-it that we have posted. And if you visit, you'll see it. It's scattered throughout the entire organization. It's called our alignment slide. And on there, it shows where we aligned with the Chief of Naval Operations, our NUWC command, and then NUWC itself. And it's the mission priorities across all of those. And in addition to that, across the very top is our vision. And our vision is undersea superiority today and tomorrow. And that's why we're here. That's why we're all here to maintain undersea superiority both today and tomorrow. And there's 3 steps in getting through that. There's the people, the process, and the results to maintain superiority through innovation. So let's talk about the people part first. It's known from an early age, next slide. It's known from an early age to get people interested in science and technology, you have to start at the earliest stages. And NUWC is involved all the way starting in grammar school to get people interested in science and technology. One of the things we do working with 4th grade classes, we work with a science club. And in there we teach kids like how to make ice cream. And they learn the understanding of how you go from liquids to solids. We do the battery made out of the lemon and get kids working interested into it. Another thing we do in middle school, a program I find particularly interesting, is Green Light for Girls. Okay, at the middle school age, and I was always down in my father's workshop, working with my hands. I have all the scars to prove it. And girls really don't often have that opportunity. So the idea is we get them involved working with tools, working with a workbox, a toolbox, working with wires, how to solder, how to build things, so they're not frightened off when they start going into classes where they have to work with their hands. We get them some experience doing that. Through high school, one of the programs that we have is called the UTAP program, the Undersea Technology Apprenticeship Program. And we run 3 sessions with that. It's a 3-week session with 25 students in each class. And we really kind of run them through the science and the engineering discipline, where we have them come in and we define a requirement. They need to make a vehicle that has to work underwater and go do a series of maneuvers and run an obstacle course. And they have to write design requirements, and they write test data and results, and they keep track of all that while they're going through the entire 3-week program. And it really gives them some insight as to, hey, this is what engineering is. It's not just building the thing, it's understanding the physics and the engineering behind it all to make it all happen. And lastly, we talk about our college internships program. I was actually a college intern myself, and it's proved very successful. And if you look, many of NUWC employees have gone through each of these programs. So we have one guy, Yori Coralento, actually started as a middle school student, now an employee at NUWC Newport. We also have Dr. Erin Gausch, who actually started as a high school internship program, and Ms. Hathaway, who started also in the high school program, now working full-time at NUWC Newport. So we've seen success with these programs to help groom that next generation of scientists and engineers. Another program that we participate in is the International Seaport Challenge with Raytheon. And in this video that you're watching right now, you're going to see both gray shirts. Those are the NUWC folks, and the red shirts are the Raytheon folks. And in this program, this is an international Seaport Challenge where teams come from all over the world, from both middle school and high schools, some as far away as New Zealand, to come and participate in this event. It was held at the University of Massachusetts in Dartmouth. And in this, you can see the robots that they put together, run them through an obstacle course, do some testing on that, and try to see who can compete and win. So it's a very popular event. Over 200 teams participated in this year. So when we talk about processes, I've heard a lot of talk about the OTA, the Other Transaction Agreement. And we're really excited about this because here's an opportunity where we start trying a non-traditional acquisition effort. And it allows both traditional and non-traditional companies to participate in this. So rather than me talk more about it, let's hear it from Susan Farley. Susan, take it from here.
On June 18th, the Naval Undersea Warfare Center Division Newport held a press conference to announce the award of Other Transaction Authority to the Undersea Technology Innovation Consortium.
This award reinforces Rhode Island as the DoD focal point for undersea and maritime technology innovation, with particular focus on undersea vehicles, sensors, and sonars, payloads, communications, electronic warfare, and applicable enabling technologies such as quantum computing and advanced materials.
We are really today connecting more directly and more efficiently the innovators and the solution seekers.
Other Transaction Authority streamlines acquisition efforts to get the newest technologies to the fleet faster.
We invite all technology companies, large and small, who have undersea and maritime expertise to join us and be part of our consortium team.
There's no better place to conduct this work than right here in Rhode Island, where the expertise that you all possess continues to push the envelope.
For Naval Undersea Warfare Center Division Newport, Susan Farley.
Thank you, Susan. So as we talk about our next step, results, the results of these efforts and how they participate and contribute to innovation in undersea warfare. Unmanned vehicles. This is our future. The world is going unmanned, particularly with the undersea realm now moving in that direction. We've seen a lot of it in the air community for a while, but it's growing exponentially now in the undersea realm. We can no longer afford to take a $2 billion submarine and run it through every single mission, right? There's too many bad guys, there's too many adversaries out there, and the capability, I'm hearing now more talk about peer adversary than I ever have in my history of my career at NUWC. I mean, our competitors are getting more and more challenging to be able to compete in that market. So now we can start moving our sensor and mission capability off board the platform, and for our extra large UUVs, run missions directly from those, not even requiring a submarine. That's the future to where we're going. So part of that challenge is endurance, right? We got to make these things run a long time. Submarines, nuclear powered, go very, very long. So one of the efforts we're looking at, lithium-ion batteries we've been using, the challenge with them, can't put them on board a submarine, lots of risk. We've been researching some methods by which we can make them safer, encapsulate them in different capabilities. Another thing we're looking at is fuel cell technology. Here we're looking at a proton exchange membrane. This uses hydrogen and oxygen, and you can throttle this just like a vehicle. You're just limited to how much fuel you keep on board on the vehicle. A little bit safer than lithium-ion batteries, but still a challenge. So any effort on battery power technology or fuel cell technology and endurance is the challenge we're trying to meet. Another new sensor technology we're looking at is a thermoacoustic sensor. Okay, this is a little bit different. It's actually made out of carbon fiber nanotubes, real thin carbon fiber nanotubes that we form. We make them into a line, make them into a grid pattern. It's a very, very lightweight sensor, very, very efficient as far as its sensitivity and capability. And we like that for unmanned vehicles because you don't have much space on an unmanned vehicle. You can't put traditional sensors on them like we do in the acoustics world. You got to go with lighter weight technology. Still in the very early stages, but it's showing some promising capability. Next, bioinspired sensing technology. This is one area that's very unique. Unknown fact, seals have an amazing capability to be able to find fish in the water just by using their whiskers. If you can blindfold a seal, throw a fish in a pool, and it'll still swim around, find it no problem whatsoever. So if you think about it, nature's had a pretty big advance time-wise to improve its sensor capability. What can we do to try to learn from them? So here's Dr. Kristen Murphy talking about the efforts we're doing in that area.
NUWC Division Newport's capital investments now include the Tech Evolution Water Tunnel to aid in rapid prototype development. The tunnel offers a controlled flow environment for experimentation by precisely calibrating and controlling the water current. The tunnel supports both traditional hydrodynamic work and NUWC's Bioinspired research, where structures and sensors in nature are modeled and mimicked. Working in partnership with NUWC's additive manufacturing facility, the Advanced Concepts Mechanical Engineering Laboratory, these designs can be modeled, scaled, and 3D printed for water tunnel testing. This partnership is termed the Tech Evolution Initiative. Dye visualization, high-speed videography, and laser measurement techniques can be used to understand prototype performance in water. The tunnel's 7-foot-long test section is entirely optical glass, which allows for these measurements to be taken from any angle. The system can be run with salt water to replicate a marine testing environment, and the system's flexibility enables NUWC to rapidly iterate and test new designs and prepare experimental prototypes for field testing.
Another biotechnology we're investigating is bats. Here's another interesting fact. Bats in large caves, there can be over 1 million bats in those large caves, and when they fly out, they don't bump into each other. Now, from a sensor perspective, they have 2 ears and they have transmitters in their nose. They have 3 little transmitters in their nose. And how do they do that with so little sensors? If you look at a modern submarine, we have hundreds, if not thousands, of sensors on board a submarine, all doing what we're trying to do. And yet these little guys can fly out of a cave, not bump into each other, and find an insect the size of a mosquito. You're actually going to hear some video here of bats flying around. You're going to hear the transmissions, the sonar transmissions that they're making as they're flying around, capturing these little bugs. Play it.
Using echolocation, these bats are able to navigate and find prey in the darkness. For decades, scientists have been studying bat echolocation to try to improve man-made sonar devices. Notice how the bat scans from left to right. Studying these beam patterns provides insight into how bats convert sound into images of their environment. In the end, we still have a lot to learn from these bizarre creatures.
Now, the technology is a long ways away, but if you could ever make a UUV as effective as a seal for it to fly around and detect things, it would be pretty amazing. Another area we're looking at is up in the Arctic area. The undersea realm is expanding now, right? With the continuing melting up of the Arctic ice, there's more and more activity taking place up in the Arctic. This video here shows the most recent ICEX event taking place up in the Arctic. We went up there, we actually had 3 submarines that penetrated through the ice, and you're going to see where we're doing a variety of acoustic tests, practicing working in that environment. That's a cold water dive. You're going to see a couple of pictures of the submarines actually coming up through the ice, which is pretty unique. This is the first time. There's actually a photo showing 3 submarines, 1 from the UK, 2 from the United States, all surfacing, all with up in one picture. Never done before, first time. We do this about every 2 years to get a better understanding of what's going on. And I just read in the news recently, Maersk ran their first cross-Arctic trip with their shipping lanes. They're actually looking to make their trip shorter, now operating up in that region. So part of that now is we're doing some research on low temperature testing on composites. Turns out lots of material testing on composites except at low temperatures. But for us to operate in this environment, you need to have an understanding of, hey, what's the effect on these things? There's actually very little research on the colder regions. So if you look at UUVs, buoyancy is always a challenge. So there's a desire to go to composite technology to make them lighter so you can put more payload onto them. But we got to make sure they can operate in this environment. That's one of the areas that we're looking at to be able to do some research. Linux container systems. Interesting fact, today's modern sonar system has over 20 million lines of code, right? When you get that much code and you got to move code around to different places, you got to start looking at being able to containerize this code. If we're making software for unmanned vehicles, we'd be able to move it around when having to write a new baseline of software. So it's called Linux container technology. It follows commercial standards and allows for modular software. Machine learning, data science. This is one area that we're hearing more and more about everywhere we go. I think every presenter has touched on it to one degree or another. And there are a variety of applications that we'd be looking to apply towards for the undersea domain. Cyber anomaly detection being one of them, right? You get 20 million lines of code, you get all that code executing. The system itself could start recognizing when strange things are happening and what's going on in that area. Autonomous systems, what we can do with that. UUV swarming, and also for sonar technology. If you think about how long it takes to train a sonar array, to watch a waterfall display and understand where the target is, there's got to be advancements we can make with that with machine learning to simplify the whole process. Cybersecurity. This is the war that's happening right now, every day, thousands of times a day. Our systems are being attacked. And there's two threats, or there's two fronts that we need to worry about, right? One of them, are they affecting our systems and we don't know about it? Are they going to make us lose confidence in our systems? If you think back to the start of World War II, there was a radar system on Hawaii that was detecting the incoming airplanes that the Japanese were sending. But the fact is, it was a relatively new technology, and the operators didn't have confidence in the machine, and they thought it was a flock of birds, and they said, we're just going to ignore it, and we're going to shut down for the night. Little did they know, it was an actual invasion. They just didn't have the confidence in their system. So that's the danger with us. If you're running a sonar system, is that really a contact? Is it a fake contact? Is there something happening to our software that's being affected through a cyber attack? The other side of that equation is what's happening to our industrial technology, right? The United States spends over $600 billion a year on our defense system, more than the next 9 countries combined. But if other countries are stealing that technology, that doesn't help us very much. If you look at some pictures here, this is China and the United States technologies in a variety of aircraft and UAV type technologies. And it's amazing. Take a look at them and see how much they look alike. From fighter jets to heavy lift aircraft to gun technology to unmanned vehicles. These are amazing how much these look alike, and the last one here in particular. Now, I really want you to think about this from an engineering perspective. I know I got a lot of scientists and engineers in the room, right? If I broke you up into 2 halves, and I separated you by 12,000 miles, and I gave you some requirements to make me a medium-sized UAV, what would be the odds that they would look that much alike? I mean, it's almost nil. It's pretty amazing that they're that much alike. So clearly, we've got to do better in that area. So I've been talking about people, process, and results, and one of the areas that we've been looking to tie all this together and started to demonstrate technology is our Antex event. All right, this is our 4th year doing this, and it has grown each and every year. This year we have 55 participants participating. We have 17 unmanned underwater vehicles, 6 unmanned surface vehicles, and over 30 exercises taking place. It's really proven to be successful, and it's a great venue. This next video here shows you some of the highlights captured from last year's event. And I'm expecting this year's event to be just as exciting. So I've been talking to you about a variety of technologies and innovations taking place in the undersea domain, and all the innovation that's taken place. And quite frankly, this is just a small subset because of the venue we're in with Distribution A. There's lots of limitations of what I can talk about. But the scary part is we're not the only ones working in innovation for the undersea domain. Our adversaries are also doing the same thing, which is why I'm relying on everybody in this room to form a team and help out and help resolve so that we can maintain undersea superiority for both today and tomorrow. Thank you very much.
I think we have time for a question or two. Tim, Molly? Yes? No? Yes? Yes? Okay, yes. Anybody? From Mark or Ron?
Yeah, there's one over here.
Randy? Yep. Please.
Yes, so Ron, I have a question for you. During the day-to-day, there's a lot of discussion about moving innovation to the field, and it's slow for a lot of reasons, and contracting was discussed. But along the way, the warrant holders took a few shots too. So I was I'd like to give you an opportunity to talk about the warrant holders and how they really aren't holding up the works, as was sort of implied.
Yeah, it's funny that you say that. Yeah, the warrant holders do get a lot of abuse for that. But the reality is they play a very critical role, and I really started to understand that. Not only am I the technical director at Newport, but I'm also the deputy warranting officer for undersea systems. And with that, I report to CO5, Admiral Selby. And they're pretty much the engineering arm or the engineering discipline to make sure that we're executing safely and doing the proper things, right? Not that program managers aren't, but program managers are executing their programs. But consider the tech warrants to be that independent party to watch those folks to make sure that things are being done with the proper discipline. So the best recommendation I tell everybody is engage with these folks early. As a department head, I met with them every month, and in my DWO role, we have a bi-weekly conference call. Just to make sure everything that's going on, any issues going up with their programs. But they do play a critical role. You know, they do kind of get some pressure every now and then. But for the safety of our sailors, it's very important with the role that they do, and I've recognized that. Thank you.
Any other questions?
It's the end of the day.
End of the day.
Did you guys know there's a bar out there?
Yeah, they do. Last going once.
Any questions?
Anybody?
Oh, one back there. Go right ahead.
Yeah. Please, go ahead. Yes, sir. Go ahead, back first. We'll go in the back first.
Gentleman in the back.
Go ahead.
Near the door.
Just stand up and shout it out. Yeah.
Admiral Carr.
Thank you for two very interesting talks. From the Woods Hole perspective, could you just talk a little about how you view our international partners and competitors compared to where we are, including trends and direction?
Okay. So the question is, how do you view our international competitors? And clearly, China's the one top of mind for everybody. It was interesting, earlier this year, I had a visit from the director of the Qingdao National Laboratory for Marine Science and Technology, and he was the one who laid out, my vision is to make the ocean transparent. They are putting on, what I saw was an amazing amount of resources into both conventional shipbuilding, into new technology, into training. It's something that the academic institutions in this country could, in some sense, only dream of. I mean, it's in the sense, in the 60s, after Project NUWC, the CNO was still Admiral Burke, very long duration CNO, and one of the things he did was create 10 years of oceanography where he multiplied the investment in fundamental ocean R&D by a factor of 10. He took what were two institutions, Scripps and Woods Hole, and added 8 more. It was that level of investment that transformed it, and I see China doing the same thing, and I don't see us doing that. So it's unsettling, I think, is probably, Admiral, the best way to put it. I think in terms of scientist to scientist, we still have a lot of the best, but when you look at the quality of the papers that are starting to come out in some key areas like acoustics, they're right there. And when you look at their ability to marshal data and manufacturing and what I like to call customization at scale, that is, if you want a vehicle, they'll go and make it for you in a few days. We just don't have that integrated sense, that end-to-end and that long-term view, and that's concerning.
Joe, I think, Joe, did you have anything?
Great discussion on technology. I'd like to go a graphic that Admiral Richardson once had showed operational performance and tech insertion. And they marched together pretty well for some point in time, after which it flattened out. And tech insertion no longer really had any additional meaningful benefit to the operations. So I'm wondering what we're doing in order to ensure that we can optimize the use of these technologies from an end user standpoint.
Yeah, when you come to optimizing them, I'd say the best way to do that is get it into the hands of the warfighter and look at the effectiveness of those systems, right? So we'll often do, I'll call them, developmental systems we'll put out and see the effectiveness of them, how they're working. I know we've brought systems in, like for operators, we'll bring operators in, have them test different variants of software, see what they like, what they don't like. We've done that for both the sonar and the combat side of things. So there's ways you can do that to measure how effective it will be before you go forth with a full-scale acquisition. So.
Let me add a little more to that. I think that's a great question. When you start thinking of swarms of UUVs, you can't just run them the way you run a single Remus vehicle, for example, with a few people, pretty manageable data set. When you start getting tens, hundreds, or thousands, and you've got to bring in machine learning and AI into that process, that extracting the patterns, that modeling, and that constant improvement. I can remember deploying 12 moorings in the polar front in the Southern Ocean and having basically 10 data streams per float, and that's a hard data set to work through. You really needed that machine learning. And I think when you, again, to go back to Admiral Carr's comment, investing in that fundamental AI ML really opens up all of those aspects. That's what Planet Labs is doing as well. They're using lots of pretty good sensors, not one absolutely gold-plated best ever, one off. And it's really flips how you think about and manage and extract knowledge from those data sets. It's really what the DARPA Ocean of Things is trying to do as well. Lots of cheap stuff, not as good as a standard, WHOI float, but boy, it's 1,000 times cheaper, and I've got a lot more of them.
Senator.
So Mark and Ron, can you, following up from the conversation McCumming just made with regards to the, I'll say, swarm of UUVs, can you comment on the trade-off between autonomy and comms? We've heard several people talk, and if the Admiral was here, he talked about, and other people talked about him being networked. And if you're going to have a swarm or UUVs that are out deployed, the comms may not be there, autonomy. Can you share your concerns or vision with regards to how much comms do you have to have, how much autonomy will you allow, how much command and control needs to be on board the platform to potentially release a weapon?
Great question. And that is always a problem. I think we are an end member of a problem that we have in the whole Internet of Things world. So if you look at the next generation cellular technology, 5G, they're all working on that. The concern is that all these devices and cars that are moving around also have discontinuous communication. Sometimes you have nothing. Sometimes you have real gaps or low bandwidth, and yet you've got some critical decisions that you have to make. The car going around and suddenly it doesn't have cell coverage. It needs to know it can't run into a fire hydrant. So what the industry is working on is, where is that autonomy, that there's smarts everywhere. It's not just a bunch of dumb devices and I bring everything back. And it's much more adaptive. And you think about autonomy not only within the vehicle, how do I manage my power load versus my battery availability? Maybe I go through a degraded mission, but I still achieve the mission. I think about autonomy within the environment as the environment changes around or changes, autonomy within the mission. So you've got to start thinking of it as a much more hierarchical, integrated approach, and that's one where I think there's a huge opportunity space to play in. The good news is that there are, not that the commercial technologies we're just going to move them one-to-one, but there's a lot we can learn because they have a lot of the same problems. We're just harder.
Yeah, your question reminds me of, I was posed a question by somebody quite recently, and the question was, what's an acceptable loss for vehicles, right? As you start going to autonomy, the question is either you're going to fail to perform your mission or you're not going to get it back. And the question they asked was, what's considered an acceptable loss? And I know in the Navy there is some official dollar threshold that gets into certain IG investigations and such, but I'll also say, if you're firing a torpedo, don't quote me on the exact number, but it's over $1 million, and you're willing to lose that, right? Because it's serving its intended mission. So when it comes to the autonomy portion of it, there'll be that trade-off. How important is the mission to you? You're willing to lose the thing and have it come back. Comms is always a challenge in the undersea domain, definitely.
From a Newark perspective or from a Tech Warrant perspective, how are you going to manage the testing of that?
Managing the testing of?
The acceptance of that.
As far as?
Typically, we're going to test systems in a deterministic environment.
Correct.
We're going to put these systems in a non-deterministic environment. So the acceptance we need to get to is, I'm going to be in an environment that I don't necessarily know what's going to happen.
Right.
given the autonomy, how might you as a tech director say this is an acceptable amount of risk I'm willing to accept as a tech warrant holder for that autonomy that I'm not going to put it to all its paces? Because I don't know all the environments it's going to be in.
Right, right.
So, this again, sorry to be bringing in the private sector, but there are lessons to learn. If you look at Uber, when they come into a city for the first time, they have a certain number of drivers, and they say, well, we're going to just kind of deploy them, we think, semi-randomly, and here's the average wait time between request for a ride and actual pickup. Over the course of about 60 days, that drops roughly a factor of 5. And it's because they are learning the patterns. They are taking that data and then improving the models constantly, so that eventually they get down to a level and they say, that's good enough. But it's that constant learning rather than say, I'm stuck. I've got one vehicle out there and it is what it is. When you have these networks and couple that with data and models, you can actually begin to have a much more dynamic approach. And if devices are $100, then you don't care so much. They all have to start playing together. That's where I look at China and the AI, the ML investments, as well as in the manufacturing. That's the game I think they're playing.
Yeah, and I would say from a tech warrant perspective, when it comes to the real testing requirements, there'll be some defined parameters that you can put for the system to see how it operates. Granted, machine learning, it'll get smarter, it'll learn more as time goes on, but there has to be some defined requirements you can have for a system. We're not just going to buy it for the sake of, hey, we hope it works, you know.
All right, Mark and Ron, thanks so much for sharing your thoughts. Everybody, thanks for hanging in there. Big round of applause for these guys. Mark, thank you very much. Let's do a quick picture here. Thank you. Thank you. Great job, guys. Thank you.